So hi all, welcome back to malware analysis. I'm Jay Lavanya, assistant professor of CSC department. So today in this video, we are going to discuss on the topic called typical malware behavior. Okay, so let's dive into the topic. So what is meant by typical malware behavior, right? So typical behaviors exhibited by malware provide some insights into how the malicious software operates and the actions it commonly performs on a compromised systems. So that is what we used to call as a typical malware behavior. And in this typical malware behavior, we have some sort of behaviors where we used to serve where the malware is working, right? The first one is that downloaders and backdoors. So during a malware attack, the threat actor will often use a range of some trojans to infiltrate a vulnerable system. The infiltration is followed by the creation of a downloader or a backdoor that allows the attacker to gain some remote access over the targeted system. So reversing these applications requires some analyzing how the downloaders and the backdoors run in a sandbox environment, as well as understanding their processor, registries, network activities, and file systems. Okay. The reverse engineer will also use a debugger and a disassembler, which could be supported by a decompiler and a range of helpful tools. Okay. And second one, that is credential stealers. So credential stealers are a type of malware that searches for passwords saved on a target mission and transfers them remotely to an attacker, like using some HTTP or the email, right? And the malware authors typically use the software that waits for users to log in, and other common techniques involve the uses of programs that log keystrokes and tools that dump the credentials stored in the windows, like password hashes for some offline tracking, right? And second one is that process injection. So this is a malware attack technique that gives some advisories the ability to deploy the malicious code that mimics the legitimate applications. Okay, and running code in the environment of another application may grant access to its process memory or the network or the system resources and even the authorized privileges, right? The code is typically inserted into some common processes like, for example, svc host.exe or reg svr32.exe, something like executable files, okay, similar to that. And these grants the attacker an improved level of persistence and stealth, right? So some of the kernel modules which can be configured to prevent some forms of process injections based on the behavior patterns that are identified during the analysis of the attack. Okay. Okay. The next one is that DLL and direct injection. So DLL, as we have already discussed in the unit 1, so you can just check out the videos which I posted already. So DLL is a dynamic link library injection. So it is a type of process injection that requires the threat actor to write the path to a DLL inside an application's process, and then using a remote thread to invoke the execution. And this code injection methods like the set Windows hook EX API or the manipulation tactics like a create remote thread, which can be used for DLL injections on the Windows, right? And in contrast, a direct injection involves the direct placement of a shell code into another process. And the process replacement is where the malicious code will substitute an illicit process for a genuine one, helping the code to hide some legitimate processes. Okay, and this is usually done by pulling the genuine code from the memory of the target process using a kernel function like n2nf map view of section, and then assigning a new block of memory for hosting some illicit code. Okay. And next one, like if you take for the hook injection, So the malware creators may also use some hook injection method to load and run the malicious code within the environment of the another program. So mimicking the original execution while also gaining access to the memory processes. In addition, the technique may also be used to intercept API calls that feature the input and the output parameters. So once the API is hooked, the threat actor can control the relevant program's execution path and point it to the malicious process of his or her own choice, right? So this is all about the hook injection. And next one, like if you take like APC injection, so APC or the asynchronous procedure call injection describes the technique of the attacking malicious code to the APC queries of a thread inside a process. Infected APs will then tell the thread to execute some other command before initiating its standard execution path. An example of them is that atom bombing. So atom bombing, this involves the utilization of queued APC functions to invoke some malware. Previously, it is used to add some character strings to the global atom table. Okay. And next, we will discuss about some typical types of the malware behavior. So first of all, they have given is that persistence. So what is meant by persistence? So this persistence, what will do is that it ensures the malware survivors, reboots and stay active. And what kind of technique they will be using is that they'll be adding entries to the registry run keys or the windows and installing some itself as a service or a scheduled task and copying to some startup folders and modifying some boot records. So all those things like MBR or VBR infections, right? So all those stuff goes for this persistent. And second one, like evasion. So here it avoids the detection by some security tools or analysis. And what kind of technique you use is that the code obfuscation or packing, which corresponds to the compressing or encrypting the payload. And you have to check for the sandbox or the VM environments, right? Such cases. And the third thing, disabling or bypassing some antivirus and firewalls. And fourth one, by using some polymorphism or metamorphism, you can able to get or you can able to generate some of the common aspects where it is used to change the code signatures, right? Okay. And next one is that a privilege escalation. So this privilege escalation, it gains some higher access rights and exploiting OS or the application vulnerabilities and using some token impersonation or stealing some admin credentials and dropping the rootkit for kernel level control. Okay, so all those things come to for privilege escalation, right? And next one is that propagation or spreading. So this infects the mod system and there is self-replication, there is worms or exploiting some network vulnerabilities and email attachment infected USB drives, file infection of executables or the macros. Okay. And next one is that C2C communication, that is command and control C communication we used to say. So this is also a very, very important topic in case of this malicious. So once installed, malware often establishes a communication with the command and control, or it uses some predefined attackers to remotely control the infected system. So first it has to establish a connection. So malware typically uses some HTTPS or HTTP and other network protocols to communicate with its CNC server. It also may use a hard-coded IP address or a domain name, or it may use some domain generation algorithm, that is DGA, to generate a list of potential CNC server addresses. Okay. Okay, next one are like receiving commands. So the CMC server sends a commands to the infected system, instructing it to perform some various malicious activities. So these commands can include downloading the additional malware or the stealing data, launching attacks, or updating the malware itself. Okay. So next one, like if you are going for exploiting the data, so here the malware often steals some sensitive data from the infected system and send it to the CNC server. So this data can include some username, password, credit card numbers, personal documents, and other confidential information, right? And next one, like botnet activities. So the infected systems may be incorporated into a botnet network of compromised computers, which can be controlled by a single attacker. So botnet can be used to launch some distributed denial of service attack or send some spam emails or perform some other malicious activities. Okay. So this is among command and control communication. Okay. And one more time, I just want to add some point to this evasion is that so this evasion, it has some techniques like obfuscation. So the malware can obfuscate its code to make it more difficult to understand and analyze. So this can involve using some encryption, compression, or other techniques to hide the true nature of the code. Okay. And next one, like sorry, and polymorphism and metamorphism. So this polymorphic malware changes its code with some each execution, and also this makes it difficult to rewrite the entire code with infection, making it even more difficult to detect. Okay, and next one, anti-debugging and anti-virtualization. So malware can detect if it is being run in a debugging environment or a virtual machine and alter its behavior to avoid the analysis. And next one, like process injection. So malware can inject its code into some legitimate processes to hide its activity and event detection. And next one, like hooking. Malware can hook the system calls or other function to intercept and modify their behavior. So this can be used to hide some malicious activity or steal the data. Okay, so the next one is that malicious payload execution. So this is used to perform some intended harmful actions, and examples like data theft, disruption, surveillance, as well as monetization. And data theft, like it's used for key logging, credential harvesting, or copying the files. And second one, destruction, like wiping the disk or encrypting some files. And surveillance, like activating microphone or webcam or screen capture. And monetization, like crypto mining, air fraud, as well as extortion. Okay, and next one, like it is a data exfiltration. So it steals some sensitive data from the victims, and updates, like techniques used is that for updating to attacker control server and hiding data in its technography or some encrypted archives, or using some cloud services, FTP, email, or some covered channels. Okay, so for all those stuff, we have this exfiltration process. And last one is that anti-forensics. So this anti-forensics, which makes analysis difficult. Okay, right, that's a goal. And the techniques uses that, like uh, I mean, log wiping and time stamping, encrypting some communication and payloads, right? And apart from that, fragmenting the code into some multiple parts. Okay, for all those purposes, we are using this. Okay, and next is then, so this is some diagrammatic representation. Like as I discussed, like it has some malware behavior where the core actions of the malicious software is done. And second one, like installation and persistence, some methods to establish the presence. Okay, and the communication, that is C2C. Here the network, like network interaction for the command will be doing. And next one, like malicious activities, harmful actions on the systems will be done over here. And next one, like evasion techniques, strategies to avoid some detection, right? So all those things comes under this malware behavior analysis. Okay. Next one is the signs of malware infection. So let us see what are the signs. So while some malware is designed to be invisible, like many infections leave behind some noticeable symptoms. Being aware, like if you're there will be in film, you could have seen like if the thief or something, some persons, they are doing some theft in the sense they'll be leaving some noticeable symptoms like what is that? We used to say like. Something like they used to keep and go. Okay, by means of that we can able to get a clue from it, right? So similar to that here also, like many infections will be leaving some symptoms. So based on these signs, we can help to identify and address an infection earlier itself. Okay, so first of all is that performance issues. So a noticeable slowdown in your computer's performance, including some sluggish boot up times, or the slow application launches, and high CPU or the memory usage can be a major indicator, right? So the malware, especially if you take like crypto miners or the botnet clients, can consume some significant uh, system resources. And next one, like unusual network activity, a sudden and an unexpected increase in network traffic, particularly outbound traffic, could mean your machine is communicating with a C2 server or participating in a DDoS attack. And you may also see some unusual DNS queries or connections to suspicious IP addresses. And next one, like pop-ups and unwanted ads. If you're constantly bombarded with some pop-up ads, especially when not browsing the internet, strong signs of adware or the spyware. So these ads may also redirect you to some malicious websites. So this I think all might have seen, right? And next one, changes to the system settings. So here the malware often modifies some browser settings like the home page or the default search engine, right? Disables some security software or changes some critical system files. And if you find your settings have changed without your consent, right, and you're unable to revert them, you may have some malware. Okay. And next one, that is last, is that file encryption or deletion. So if your files becomes inaccessible or renamed with some strange extensions or some completely deleted, you could be a victim of ransomware or some destructive worm. So the attacker may leave a ransom note demanding the payment for the decryption key. Okay, so these are can say like signs of malware. And next one, in malicious activity also, depending on the goal, we have some data theft or the data encryption, that is ransomware, you all know. And system damage may occur or may can corrupt your system files. And then resource consumption like CPU or the memory usage, the network bandwidth, all those stuff. And spreading to other systems like via removable media, infected more devices, and expanding, the attacker's reach. Okay, next one, key logging. The malware can record some keystrokes and entered by the user, like capturing the username, password, and other sensitive information. Okay, and like spyware, so malware which can monitor the user's activities such as browsing history, email communication, and social media interaction. And then last one, that is rootkit functionality. So here some malware analysis employs some rootkit techniques to hide its presence on the system and evade some detection by some security software methods. Okay, so these all comes under the malware infection. Okay, so in this particular video, we have discussed about the typical malware behavior and its various techniques and how it is used and how it is behaved, right? And we have discussed on various common malware behaviors which should be involved in this new era, right? And then the signs of malware infection. If you are getting some sign in the sense, so based on this, we can able to say that these are the signs of malware infection. Yes, we have listed some of the techniques, right? I hope this video will be very useful for you. We will see you in the next video. So thank you all.